Hi everyone and welcome to this video about arithmetic sequences. In this video we're going to focus on how to find the nth term. Before we start the video, please remember to like and subscribe if you enjoy it, and if you have any questions please leave them in the comment section down below. If you would like me to make a maths video on another topic of your choice, you can comment that down below as well. The definition of an arithmetic sequence is a sequence that has a common difference between its terms. We can see for a sequence like this, the difference between consecutive terms is the same. This is what we describe as the common difference. So between 2 and 5, we're adding 3. Between 5 and 8, we're adding 3, and so on. An arithmetic sequence can also have a negative common difference. We can see in this case, going from 5 to 3, we would subtract 2. From 3 to 1, we would subtract 2, etc. So just to reiterate, if we're talking about arithmetic sequences, we must be talking about sequences with a common difference. For example, our prime numbers of 2, 3, 5, 7, 11, that is not an arithmetic sequence because the difference between the numbers is changing each time. What is special about arithmetic sequences is we can very easily find an algebraic expression for the nth term. What I mean by the nth term is the number of the term, not the value of the term. We can write this as the first term, the second term, the third term, etc. Below would be the value of the term. So the nth term is where we're taking an unknown variable and replacing the number of the term with n. So our goal is to find how to represent the value of the term using this variable n. To find a general formula, I need to step away from the numerical case, and I'm going to use some algebra instead. What I'm going to do is define the first term of my sequence as a letter. Okay, so I'm going to represent that first term with the letter A. Then I'm going to say that because it's an arithmetic sequence, I know that I'm adding or subtracting the same number each time, and that is what we call the common difference. I'm going to use the letter D to represent the common difference. Here I'm going to say I would add D to get from the first term to the second term. So in terms of the algebra, the second term would be A plus D. Well, to find the third term, I'd have to add D again to the second term, and I would find that that was A plus 2D. Let's take a moment to compare the number of the term and the value of the term. For the second term, we can see that I've added 1D. For the third term, I've added 2D. And if you do the next step and find the fourth term, you'll notice that it's A plus 3D that is the expression for it. So comparing the value of the coefficient of D, which is the number in front of D here being multiplied to it, in this case it's 1 times D, in this case it's 2 times D. Comparing this number with the number of the term, we see that it's 1 less. So we can set up a general formula for the nth term by following this trend. We know that we have to start with A, and we're going to add on a multiple of D. And in the case of the nth term, well, I would have n minus 1 as the coefficient of D. And so this expression that we've reached at the end is the nth term formula. So just to reiterate, A is defined as the value of the first term, D is defined by the value of the common difference, D can actually be positive or negative, n is an unknown variable that we're using to replace the number of the term. Let's take a look at an example together. Here I've got a sequence 5, 8, 11, 14, 17, and it's going to continue upwards. I would like to find the nth term of this sequence. What that means is I'm going to use the variable n to represent the number of the term, and I want to know how I could calculate the value of the term using n. So to begin with, I'm looking at my formula and I see that A and D are still unknown to me. I can find A very simply. That is going to be the first term of my sequence, so A equals 5. To find the common difference, I'm going to figure out what I'm doing to the first term to get to the second term. That is positive 3 or plus 3. And I'm going to be doing that each time. So the common difference in this case is 3. So the nth term formula for this sequence would be 5 plus n minus 1 multiplied by 3. We can simplify this formula by expansion and combining those two constants. So now we've found the nth term formula for our sequence, let's just see how we use that. For my first term, n is 1. Let's put n equals 1 into our nth term formula and see what the value is. And as we expected, the first term's value is 5, just like our sequence in the question. Let's try the fifth term, so n equals 5. And calculating that, we find it indeed works out the value to be 17. Following on from the example then, now I'm asked to find the 100th term of this sequence. I just worked out the nth term, so in this case I can replace n with 100, as I'm looking at the 100th term. So to find the value of the term, I simply plug that into my formula, and that works out to be 302. So that would be the answer for the 100th term of the sequence. The last part of this example then is asking us if 243 belongs to the sequence. What you might have noticed already is that every value of n is going to be a whole number. We start with n equals 1 and we're just counting upwards in the whole numbers, just our counting numbers. So if we calculate n to be a fraction or decimal or something like that, we know that it cannot belong to our sequence. So we know that the value of the term should be equal to 2 plus 3 times the number of the term, and we're going to set that equal to 243, which is the value of the term, and so n should work out to be a whole number if 243 belongs to the sequence. So subtracting 2 from both sides, and dividing both sides by 3, we find that n is 80 and a third. It is not a whole number, so we can say that 243 is not part of the sequence. Let's take a look at this longer, slightly wordier example. The first term of an arithmetic sequence is 8. So from this first sentence, we can gather that when n equals 1, the value of the term is 8. The 20th term is 65. So when n equals 20, then we know that the value of the term must be 65. And we're asked to find the 50th term. So from the last example, we saw that when we're asked to find the whatever numberth term of a sequence, we need our nth term formula filled out with the value of a and the value of d. In this case, we're not given either of those values, so our first goal is to work those out. So the first term of an arithmetic sequence is 8. That means a must equal 8. However, I still don't know the value of d. So I can take the value now of 8, insert it into the formula, and use the second case where n equals 20. I don't know the value of d yet, so I'm keeping that as an unknown variable, and we know that the value of this is 65. I can now rearrange and solve this equation for d, so subtracting 8 from both sides and simplifying, and now dividing by 19, I find that the common difference is positive 3, so that means the sequence is getting bigger, and if we look at the question, indeed it is. The first term is much smaller than the 20th term. Now I can fill out my nth term formula. So 8 plus n minus 1 times by 3 is how I find the value of my nth term. Finding the 50th term then is 8 plus 50 minus 1 times by 3, which is 155. This is a slightly different example. We're asked to find the first term over 100. So once again, I'd like us to rely on our arithmetic sequence's nth term formula. So let's just write that down. A plus n minus 1 times by d. I'm going to find that the first term a is 3. I'm just going to keep n as n because I'm finding my nth term formula. And I can see that the difference, the common difference between my terms is positive 5. So I'm just going to times by that. This is going to give me my nth term. I can simplify this now to find 5n minus 2 as a simpler way of writing this nth term formula. And I'm asked to find the first term over 100, so 5n minus 2 must be greater than 100. And if we've solved linear inequalities before, then we should be able to do this and find the first whole number value for n. So we would add 2 to both sides, and then divide both sides by 5. And we know n must be a whole number, so we must take the value of 21. If we haven't solved linear inequalities, you can use trial and error, placing in values of n until you find the first value of n that gives you a number greater than 100. Let's look at this final example together. Here we've been told that the 8th term, so when n equals 8, corresponds to the value of minus 42, and when n equals 16, that corresponds to the value of minus 74. We're then asked to find an expression for the nth term. However, we've not been given the value of a or the value of d, which will both be necessary if we want to write down the nth term formula. So we can only work with what we're given. We'll start off by writing an expression using this first pair of numbers. We know that 8 is the value of n, so a plus 8 minus 1 times by d. I still don't know the values of a and d. However, I know that this must work out to be minus 42. Similarly, I know that a plus 16 minus 1, so when n equals 16, the value must work out to be minus 74. And you might have noticed that I've actually set up a pair of simultaneous equations. I can simplify this now to be a plus 7d minus 42, and a plus 15d equals minus 74. Subtracting these equations from each other to remove a, we'll find as minus 8d equals 32. Dividing both sides by minus 8, I get d is minus 4. Now I can replace d with minus 4 in my equations, so a plus 7 times by minus 4 equals minus 42. And a would work out to be minus 14. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.